Formula is volume is pi r squared h. But did they tell us the radius? What did they give us in the description? The diameter. So how do we find the radius? What do we have to do with that 6.5? Divide by 2. Good. So pick up your calculator. Radius is going to equal 6.5 divided by 2. And who got 3.25? Good. All right. And then what did they say in the description? What's the height? 10. Yep. H is 10. So go ahead and grab a calculator. And to find the volume, it's going to be pi. And then the radius, which we said is 3.25, times the height. So take a minute and type that in. All right, what did you all get for your answer? Cortez, what you get? 331.9. Anybody else get something close to that? All right, good. And it would be centimeters cubed. All right, now let's look at this second shape. Is that what you said, 331.9? Okay. All right, now let's look at our second shape. Let me see if I can extend my page. 1 second. To the right. Okay. So we have two shapes here. This one at the top is half of a sphere. So in your note packet, the sphere, formula for sphere, is on page 19. So go to page 19 in your pink packet. So we're going to figure out what the sphere is, and then we're going to divide it by 2. Because it's not a whole ball, it's half of a ball. Now, what does this 12 here represent? Is that 12 the radius or the diameter? Diameter, good. So again, we have to take that number and divide it by 2. So our radius is 6. So we're going to start by finding the volume of the sphere. So volume of the sphere is 4 pi, and then it's r cubed over 3. So go ahead, pick up your calculators and type that in. that would be 4 pi 6 cubed divided by 3. But that's for a whole sphere. So a whole sphere is 904.8. But we don't have a whole sphere, right? Because that's just half of one. So we need to take that number, that 904.8, and divide that by 2 because this is half. That's half. So let's go ahead. Oh, I don't know why I wrote it that way. I'm sorry, y'all. Let me fix that. 904.8 divided by 2. So take that 904.8 divided by 2. And that's going to give you 452.4. So that represents the top half of the shape. What do we have at the bottom? What shape is this at the bottom? So this part here that I have highlighted in green, it's another prism, but it has a circular top and bottom. So we call that a cylinder. So formula for volume of a cylinder is the same formula that we just used for the first question, because that Campbell's can is also a cylinder. And that would be volume is pi r squared h. The radius of the cylinder is the same as the radius of the sphere. And what's, yep, it's 6. And what's the height of the cylinder? 13. So go ahead, pick up your calculators. And that's a whole cylinder. So we don't have to divide that by 2 because that's the entire cylinder. So that's this answer. So to find the total, we're going to add those together. I'm going to take the 452.4 plus the 1470.3. And this will be inches cubed. All right, any questions about how we work through that? So the main thing is you have to figure out what your shapes are and you find them individually and then you add them together. All right, so we're gonna actually go back to the middle part, which is what we skipped. So in your note packet, we're gonna talk about cross sections today. So go to page 8 in your notes. Now this part of the chapter is a little bit, you have to be a visual person. And we are going to do some activity tomorrow so you can also see, because this is one of those things that you have to be able to see in the 3D to truly understand. So for example, we're going to talk about cross sections. So go to page 8 in your notes. And because your notes are in black and white, and you know, it might be good for you to kind of look at how it is represented on the screen. But here, this is, you have to first of all identify what shape do we have here in blue. What would we call this shape? A pyramid, yep. And you can't see the bottom, but if you were to try to take a knife and cross, like slice off the top, what would the shape of each cross section look like? Well, this one, because this is a rectangular pyramid, if we were to put a plane and go straight across, the shape that we would see in this one, this is going to look like a rectangle. So we can have a rectangle. And if it was going straight up and down, it would look like a triangle. So here, so we have a three-dimensional figure. It has a plane of symmetry. And does anyone know what that word symmetry means? If you have symmetry, that means that one side, it looks the same as the left. Like if you were to divide it in half, it would still be equal. For this one, because this is a prism, unlike a pyramid, for a prism, you have the same shape at the top and bottom. The cross section, this green, if this were a knife and it were slicing through this prism, it would look like a rectangle or a square. It's going to look the same as the base. So when we look at this next page, go to page 9. How many ways can I cross through this so that it's symmetrical? And again, symmetrical means the same. So your first option would be to slice it in half, so select A. You can also go through it horizontally. And there's two different ways you can slice through it horizontally. So there are 3 planes of symmetry. 3 different ways that I could slice this prism and it all look equal. Okay, let's go ahead and look, let's go skip to page 11. So for this one, if you have this shape here and you were to imagine that you were rotating, if you rotate a rectangle across or around a line, it actually changes to a cylinder. That's what it's going to look like. It's going to look like a cylinder. So I'm going to actually draw it out. And I'm not an artist at all. My brother is an artist, but I'm not. So I kind of think it's better if we kind of do it ourselves. So this is what the shape is. If I rotate it around, that means it's going to have a circle. And can you see how that looks like a cylinder? I know my drawing is really not that great. But depending on which way you draw it, that's how it looks like a cylinder. All right, go to page 12. What do you think this shape is going to be when you rotate it around? So I'm rotating it around this way. So that means here, this is going to look like, this is where my circle is going to be. And it's going to come down. So what shape does that turn out to be when you rotate it? What does that look like? A cone. It looks like a cone. All right, and then the last thing I want you to do is on page 13, and we'll be finished with our notes. We'll do an activity tomorrow to kind of help. But symmetry means which one of these shapes, if you draw a line, you can't change it. If I draw a line, which one has an axis of symmetry? In other words, the left and the right would be exactly the same. So if I were to draw a line right here, is that duck divided into 2 equal halves? right now, the way it is. I can't turn it. I can't pick it up off the paper. Is that duck symmetrical? Yes or no? No. What about this statue? If I draw a line going straight down the middle, does the left side look like the right side? Is that symmetrical? No. What about this vase? Yes. That has symmetry. This is a yes. I do not know what that is. Is that a snake? An armadillo. That is very interesting. Does that armadillo have symmetry? No. If I draw, it doesn't matter if I cut him across this way, he's not symmetrical. Or if I go up and down, it's still a no. That's a no. All right, what about the light bulb? If you draw straight down the middle, and my line isn't perfectly centered, but this does have symmetry, that's a yes. Now this donut, I can argue yes and no, but I think for the textbook, they were trying to say yes. They were saying yes. I would have probably said no, to be honest. Because the way it's tilted, it doesn't look symmetrical to me, but yeah, but I would say it. And I'm going to be very lenient on this on the test. I mean, you know, if it's an obvious no, then it's a no. But if it's a donut, you know. But I'm gonna lean towards yes. And I don't know what statue or what building this is, but would you say yes or no? Raise your hand if you would say yes. Who would say no? I think I would say yes too. Okay, I skipped over homework 2. We're gonna do some more activities with this tomorrow. But that is the end of chapter 6. We've covered everything in chapter 6. The majority of chapter 6 is area, lateral area, surface area, and volume. And then we have a little bit of symmetry.